Hi guys, these are our notes from Tuesday in our systems mini unit. This one's really important. I always see problems like this on the SAT practice problems and on the SBAC test, so I'm sure there'll be one of these types of problems on either one of those. So in your table of contents on slide 5, you can fill out slide 8 today is system of inequalities. And then this little PDF you can print out if you want or just handwrite on a piece of paper. So you want to title it Systems of Inequalities. You do not have to write down the essential question, but basically, how do you solve a system of inequalities? Where on the graph are the solutions located? So how to graph an inequality. So not a system, just a regular inequality. Okay, how do you graph an inequality? The first thing you want to do is plot your y-intercept at b. So this is if you have, y and then some inequality in here, mx plus b. It needs to be in this like slope-intercept-ish form, okay? First, you're going to go ahead and plot your y-intercept at b. Then you're going to use your slope m as rise over run. You're going to graph your line as either solid or dashed. It keeps moving. And then you're going to either shade above your line or below. Shade above or below. So we're going to talk about how to decide if your line is solid or dashed, solid or broken, your teachers might have said before, and then how to decide if you're going to shade above or below. So your equation, remember, should be in the form of y and then some sort of inequality there, mx plus b. So this could be a greater than symbol. It could be a less than symbol. It could be a less than or equal to or a greater than or equal to. Okay, so just like when we graphed regular inequalities, what you're going to do is you're going to have to decide if it's solid or dashed. Instead of, we used to do like open closed, solid dash, and instead of shade right or left, you're going to shade above or below your line. So we're going to talk about the line. Is it solid or dashed? And then about the shade, if you're going to go above or below. Okay. All right, so if you have a solid line, okay, that means that you would have the or equal to under it. So if it says y is greater than or equal to, that would be solid, shaded above. If it is a less than or equal to, that would be solid, shaded below. That'd be just a regular solid line. You're going to make a dashed line or broken line that would look like so if you do not have the inequality. So shaded above, y is greater than. Shaded below is y is less than. If you have a system of inequalities, a system means you're going to have two inequalities. You just have to graph them on the same plane, and then your solutions are going to be where the shaded areas overlap. Graph both inequalities. I think I spelled that wrong. Inequalities. On the same plane. Solutions. There's going to be infinite many of possibilities. Solutions are where the shaded areas overlap. All right, so we're going to go do some examples of this. So this is like the notes part of your slide, and then the other side of your slide will be examples. So when you flip it over to your examples page, you want to write down your examples. Our example number 1 is y is greater than negative x plus 2 and y is less than negative 5x plus 2. You're going to want to draw a little coordinate plane. I did all mine like positive 10 to negative 10 in all the directions. Okay, so these are both already in slope-intercept form, so that's good. Y is greater than, y is less than or equal to. So I'm going to go ahead and start with this first one right here. Y is greater than negative x plus 2. So it has a y-intercept of 2 and a slope of negative 1. So to make that a fraction, you would put negative 1 over 1. So my y-intercept is at 2. My slope is negative 1 over 1. That means I go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1. And I just keep going basically till I end on my graph. And then you could also go the other direction. Instead of down and right, you could go the opposite and go up 1, left 1, up 1, left 1. And it still continues on the same exact line. I guess you don't have to go the whole entire graph, but normally I do. Okay, so then I have to decide, is my line going to be solid or dashed? So it says y is greater than. There's no line underneath, so that means it's going to be dashed. And it says greater than, so that means I'm going to shade above. So I'm going to make a dashed line. I still have arrows kind of on the end, but I have a dashed line, a broken line. And I'm going to go ahead and shade above. So above would be this side. I usually, you guys can't see me, but I usually take my pencil and I make it horizontal or like perfect on the line. And then I like move up on my, and I say like, is this moving up on my desk? That's above. And then if it was going down that way. Okay, then I'm going to do my second one. So I have y is less than or equal to negative 5x plus 2. So that also has a y-intercept of 2. This time my slope is negative 5, so I make that a fraction as negative 5 over 1. And that means I'm going to go down 5, right 1. So my y-intercept is at 2 again. This time I'm going to go down 5. So I got to count down 5 and then right 1. So down 1, 2, 3, 4, 5, right 1. I keep going down 1, 2, 3, 4, 5, right 1. I ran out of room. I could go the opposite. I could go up 5, 1, 2, 3, 4, 5, and then left 1. And then I've kind of ran out of room. Since it is a less than or equal to, that means it's going to be solid. And it's less than, so it means I'm going to shade below. So solid line for this one. It's a little bit harder to draw. Solid line. And I'm going to shade below. So I put my pencil on the line exactly, and then I move it kind of to the right, and that kind of goes up on my desk. And then when I shade it or like go down to the kind of like the left side, this would be my shade below. You could do a test point. That's like another option of something you could do. So where are our answers? Our answers are where those two little areas overlap. So they happen to overlap both yellow or orange and both green in this little section right here. So you always want to make that like darker, like take your pencil and make it even darker. That includes the solutions that are on the solid line. It does not include the solutions that are on the dashed line. Okay. So any of these numbers here in this little like in the little dark shaded area, those are solutions to both equations separately. So then they are the solutions to the systems of equations together. All right, let's do example number 2. It says y is less than 5/3 x plus 2. So my y-intercept here is at 2. My slope is 5 over 3, so that means I'm going to go up 5, right 3. So my y-intercept is at 2. I go up 5, 1, 2, 3, 4, 5, right 3. Kind of ran out of room to do it again, so I'm going to go down 5, 1, 2, 3, 4, 5. Left 3, down 5, 1, 2, 3, 4, 5, left 3. And then I kind of ran out of room. I have a less than symbol, which means it's going to be dashed or broken, and it's going to be shaded below since it is less than. So I make a dashed line here and to shade below. So you could do a test point, like you could test out 0, 0 and see if that works. Like 5/3 times 0 is 0, 0 plus 2 is 2. Is 0 less than 2? It's true. This side is the less than side, so I would shade it. Then I have x is less than or equal to -3. So if you notice this right here, it says x is less than or equal to +3. Did I say -3? I meant +3. This is a vertical line. Anytime you have x equals, that means you have a vertical line. This is going to be a vertical line at +3 on the x-axis. So you go to 3 on the x-axis, you put a point, and this is going to be a vertical line. Okay, it's just going to go straight up and down through that point, right? We have to decide, though, if it's going to be solid or dashed. The reason why it's a solid line is because every point on here, no matter what the y is, the x is always 3. This is 3, 1. This is 3, 2, 3, 3, 3, 4. The x is always 3 here. So that's why it's a vertical line, not a horizontal line. So then I'm going to go ahead and decide if it's solid or dashed. Since it's less than or equal to, it's solid. And since it's less than, that means we're going to shade below. And we'll have to look at which way is below here. So I'm going to have a solid line at +3. And this one, you're going to have to go on like a regular number line if you would go shade left or right. So below, the numbers that are below, x is less than. So the numbers below 3 would be these numbers on the left-hand side. So 2 is less than 3. -6 is less than or equal to 3. So all of the numbers to the left. So your answers to the system would then be where they overlap. So red and blue makes purple. So I'm going to just shade this in, this dark color of purple. And that is where your solutions lie. You want to make it dark. So it includes the numbers on the solid line. It does not include the numbers on the dashed line. But any other point here, all of these points, satisfy the system. Last example. So this last example, we have y + 3 is greater than -4/3 x - 3. So the problem with this one is that it is not in slope-intercept form. So before I can try to graph it, I first have to get it into slope-intercept form. That means you need y by itself. So I'm just going to add 3 to both sides. I get y is greater than -4/3 x, because they cancel. Oh, no, wait. Mrs. Ardis did that wrong. How do I get rid of a +3? I subtract 3. So it cancels. I get y is greater than -4/3 x - 6. So when I graph this one, I have a y-intercept at -6, and I have a slope of -4/3. That means I go down 4, right 3. So I plot my y-intercept at -6. I go down 1, 2, 3, 4, right 3. I ran out of room, so I could do opposite. I could go up 4, left 3. So up 1, 2, 3, 4, left 3. Sorry, my iPad keeps moving us. Up 4, left 3. Up 4, left 3. I look, it says greater than, so that means it's going to be dashed, and I'm going to shade above. So I have a dashed line, and I shade above. So when I look at this line, this kind of right-hand side of the graph would be my above. Next up, I have 3y - 9 is greater than or equal to 2x. All right, so it has to be in slope-intercept form, so I got to rearrange it. I don't have a ton of room over here, so. All right, I need my y by itself, so I'm going to add 9 on both sides. I get 3y is greater than or equal to 2x + 9. And I'm going to divide everything by 3. So now I have y is greater than or equal to 2/3 x + 3. This gives me a y-intercept at 3 and a slope of 2/3, which means I'm going to go up 2, right 3. So y-intercept at +3, and then I'm going to go up 2, right 3, up 2, right 3, up 2, right 3. And I could also do the opposite. Down 2, left 3, down 2, left 3, down 2, left 3. Since it says greater than or equal to, this is going to be solid. So I have a solid line. And I'm going to, greater than means I'm going to shade above. So above this line, up would be this direction. So then I just look at my graph and I see where are my, where's my graph double shaded. So that is the part where my solutions lie. So I want to make it nice and dark. You guys are probably using a pencil, you know, so you make it nice and dark with your pencil. Includes the numbers on the solid line, but not on the dashed line. All the way up into it, but not including them. Okay? All right, so that's what you guys are doing for homework tonight. So I suggest you could use 2 different colors. You could use just like your pencil and you shade lightly on one side, lightly on the other, and then just shade really, really dark where the solutions are. All right, so let's put this into our notebook. You want to do it right away. So your notes go on slide 8 on the left, and then your examples go on slide 8 on the right. And those are our notes for today. Definitely review. All right, that's all.